Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss future videos, subscribe to the channel and turn on the notification bell to receive all updates. Imagine looking up at the night sky, where each tiny light tells a story written in the language of deep time. Some of those lights, however, hide unsettling secrets. They aren't merely stars. They are the ghosts of what once was. Celestial bodies that should have vanished silently into eternal darkness, and yet have awakened. Like in a cosmic screenplay worthy of a sci-fi horror, there are stars that die and yet return. This isn't just a figure of speech. Some celestial objects defy the rules of astrophysics and seem to reignite after collapsing, as if a fragment of their soul refused oblivion. The cosmos is riddled with such enigmas. Take, for instance, Type Ia supernovae, devastating explosions of white dwarfs, the compact ashes left behind by stars like our Sun. In theory, once a certain critical mass is surpassed, the Chandrasekhar limit, about 1.4 solar masses, these white dwarfs should explode and disappear forever. Yet astronomers have identified some that, instead of being completely destroyed, appear to survive their own explosion. A white dwarf that should have been annihilated in a cosmic flash, and instead reassembles, retaining part of its mass. How can such an object escape its thermonuclear fate? Then there's the even more baffling case of SN 2006 GY, one of the most powerful supernovae ever observed. When it exploded, it shone for months with a brightness millions of times greater than that of the Sun. Scientists immediately thought of an extremely massive star that had disintegrated at the end of its life cycle. Yet, some years later, radio signals from the same region suggested that a star, or something like one, was still there. Could it be that it had never truly died? Or that a part of it remained intact, as if the explosion hadn't been total? These aren't isolated incidents. In 2018, scientists at the University of Warwick identified a binary star system where one of the components, a white dwarf, seemed to have survived not one but several explosions. A phenomenon nicknamed the zombie supernova. The white dwarf, instead of being destroyed, seemed to have undergone a series of partial explosions that merely scarred it, as if it could regenerate cyclically. It's as though we could witness multiple deaths of the same star, and each time, against all odds, it came back. But zombie stars aren't limited to white dwarfs. There are cases of pulsars, ultra-dense neutron stars spinning at incredible speeds, that, instead of slowing down and fading away as expected, suddenly accelerate their rotation. Anomalous behavior that has puzzled astrophysicists. These glitches, as they're called, appear to be clues to mysterious events occurring inside these stellar remnants, perhaps sudden reconfigurations of nuclear matter within them. As if the star, with a jolt, shook off its lethargy and decided to spin faster once more. In other cases, certain magnetars, among the most extreme objects in the universe, seem to emit inexplicable bursts of energy years after their birth. Magnetars are neutron stars with magnetic fields millions of times stronger than Earth's, so powerful they can distort the very structure of space-time around them. Yet in some instances, centuries after their formation, they emit gamma-ray flares so intense they could sterilize entire planets within dozens of light years. Where does all this energy come from? And why does it manifest so long after their stellar death? The very concept of a failed supernova also deserves attention. Astronomers have observed supermassive stars that at some point seem to vanish without a trace. No explosion, no flash, just a star that disappears from optical observation, as if swallowed by nothingness. The hypothesis is that in these cases the star collapses directly into a black hole, skipping the explosive phase. But if that's true, where does all the energy that should have been released go? Is it possible that part of the matter survives in an unknown form, perhaps trapped in a precarious balance between gravity and quantum mechanics? Even if just a small fraction of this matter managed to avoid total collapse, we might be facing a new class of astrophysical objects never seen before. Hyper-compact cores of degenerate matter, capable of emitting intermittent radiation or gravitational pulses. Some astrophysicists have even suggested that the anomalous signals detected by radio telescopes, those coming from point-like sources with no coherent explanation, could be the irregular heartbeat of these unclassified stellar remnants. Could they be the dying gasps of stars refusing to surrender to death? In one documented case in 2014, astronomers observed a massive star disappearing in real time. The Hubble telescope had monitored a red supergiant in the NGC 6946 galaxy. The star, visible for decades, suddenly stopped shining. There had been no supernova. No flash. It simply vanished. But infrared observations revealed something different, a faint residual glow, as if a searingly hot yet compact sphere was still smoldering in the dark. Scientists suggested it could be a newborn black hole, but others didn't rule out that part of the star had survived, like an ember beneath the cosmic ash. And then there are the intermediate luminosity optical transients, ILOTs, a still poorly understood category. They're not supernovae, but neither are they minor events like classical novae. Some ILOTs seem to result from stars that almost explode but then retreat, remaining alive after emitting enough energy to be noticed across the universe. It's as if a star screams, sheds a massive gravitational burden, and then decides not to die. A cosmic cry, followed by an unsettling silence. What makes these events even more fascinating is that they might not be rare at all. Some models suggest that the percentage of stars that don't fully explode, or that partially survive their own collapse, is higher than previously thought. If that's the case, the universe might be filled with zombie objects. Stars that no longer belong to the realm of the living, but that aren't entirely dead either. An astrophysical limbo where matter, bent by immense forces, continues to exist in an unstable state, releasing ambiguous signals that defy our classifications. One of the most speculative, yet enticing hypotheses is the possibility that some of these zombie stars are disguised by phenomena we still can't interpret. What would happen, for instance, if a star collapsed into a configuration of exotic matter? According to some theories in particle physics, unknown states of matter exist, like strange quark matter, that could emerge under extreme pressure and density. If a collapsed star gave rise to a strange star, it might survive as a compact, unstable object, perhaps capable of changing again over time. Moreover, recent gravitational wave observations have opened a new window on these phenomena. Some events recorded by LIGO and Virgo have shown unexpected signal profiles, stellar mergers that seem to produce objects with masses bordering between neutron stars and black holes. One hypothetical scenario is that some mergers give birth to hybrid stars, quasi-black holes, which retain a stellar structure but with entirely new physical properties. In that gravitational limbo, perhaps, lies a new form of stellar existence. Finally, there is a notion that skirts the edge of science. What if some of these reignitions weren't natural at all? Some theoretical physicists have hypothesized, though with no concrete evidence, that advanced civilizations might be capable of manipulating the life cycle of stars. For example, by injecting matter into white dwarfs to trigger artificial supernovae, or conversely, removing matter to prolong their life. A concept at the boundary between astrophysics and cosmic engineering, known as stellar culture. If we ever observed a star that dims and reignites with too perfect a regularity, or with a too precise energy signature, we would have to ask, is it really nature speaking, or is someone else behind that curtain of fire? In the boundless darkness of the universe, where every star is supposed to follow its script with mathematical rigor, These rebellious objects remind us that the cosmos is not just a predictable mechanism. It's also a realm of unresolved mysteries, where even death can be just a pause. Zombie stars are the witnesses of a universe we still don't fully understand. And perhaps, in their silent whispers, lies the next great secret waiting to be unveiled.